So before we jump into the math, let's take a brief moment to meditate. Gently close your eyes, inhale deeply through your nose, and exhale deeply through your nose. And as you inhale deeply again, think about where you're feeling some tension in your body. And as you exhale slowly through your nose, feel those spots relax. Inhale deeply. And exhale, feeling yourself relax. Let's do one more big deep breath. Hold it for a few seconds at the top. And exhale as slowly as you can through your nose. And sense some peace and relaxation. Good job, everyone. So here's a question from the College Board. It's a multiple choice question from section 4 of the SAT test, which does allow calculators. So let's have a look. It says, based on the histogram above, of the following, which is closest to the average or arithmetic mean number of seeds per apple? And we're given 4 choices to choose from. So have a look and give it a try. It's okay if you're not sure what to do. You could go ahead and even just guess. And then in about a minute or so, we'll work through it together. So statistics problems like these all deal with a set of data. So the first thing I'm going to do is actually draw a picture because the visualization will help me. Let's look at the first bar. So those are apples that have 3 seeds each. So we can think of it as there's one apple that has 3 seeds, and right on top of it, stacked right above it, is going to be a second apple that has 3 seeds. So I have 2 apples that have 3 seeds. The next bar is for apples that have 5 seeds. I have 1 apple with 6 seeds. Here are my 2 apples with 7 seeds. And then the last bar is showing me that I have 3 apples with 9 seeds. All right, so this is actually, as you may have guessed, a pretty straightforward average problem. So you may have gone about it by just saying, well, let's start dealing with the apples that have 3 seeds. I'm going to total the number of seeds across all those apples. So I'm going to have 3 plus 3 for my 2 apples that have 3 seeds. And then I'm going to have 5 plus 5 plus 5 plus 5 for my 4 apples with 5 seeds each, and so forth. And then after I total up all the seeds in all the bars, I would divide by what? I would divide by 12, right? The total number of apples. And then that would give me my average. Now I want to show you one easier way to set this up, and that could be just by saying, well, how many apples do I have with 3 seeds each? I have 2 apples, each with 3 seeds. So they're all going to have 2 times 3 or 6 seeds. And then the next type of apple are 5 seeds each, and I have 4 of those. So I have 4 apples with 5 seeds each. And then 1 apple with 6, 2 apples with 7 seeds, and then finally 3 apples with 9 seeds. And that would give me the same thing as what I have above. This is a calculator problem, so you could do either of these computations, divide it by 12, put that in your calculator, and find the answer. And what I want you to do, if you haven't already, is go ahead and do that computation, figure out what the average is, note it, and then we're going to look at a shortcut. Okay, so if you worked out the calculations that we just wrote down, you would have found that there's 73 total seeds in all those apples. And I have a total of 12 apples. So when I do that division, and I can use my calculator, I have about 6.08 seeds per apple as my average. And then what looks good is choice C. That's probably what you did, which is totally fine, but I wanted to show you a great trick for average problems that makes this a lot easier. Okay, so when we have problems like this that have these bars and they're asking about averages, there's actually a trick that we can use that involves visualization. And it entails thinking about a balance or a seesaw. You guys are familiar with seesaws, and if you think about that little triangle as being the balance point, imagine that you had a seesaw that looked like that. What does that mean? That means I have too much weight on the left. Well, what if I had a seesaw that looked like that? That means I have too much weight on the right. What I want to think about is, how do I create a seesaw and how do I position this balancing point so that the seesaw is completely even? All right, so now look at the problem. If you look at the graph, I want you to think about those boxes as being stacked apples with weight. And this horizontal axis, this line, is the board of our seesaw. And the question is, where am I going to put the balancing point so that the seesaw is even? So let me start by trying that position. Well, would that balance it? No, that would actually make it tip over to the right. So that's not a good position. Let's now think about whether we can start marching over to the right. What if I had a balancing point that was right there? Well, that's a little better, but if you look at those boxes and think about those being weights, it'll still tip a little to the right. All right, we're getting closer. Let's keep going. What if I put the balancing point right about where the 6 is? Well, that looks pretty good. I actually think that that might balance. But to check, let's keep going and see what happens if we put it at the 7. So if we put the balancing point at the 7, what would that look like? Well, that now looks like it'll tip to the left. So that tells me that so far, the best position has been right here. And what do you know? that position is in fact the same 6 that we got for our answer when we computed the precise average. So I just wanted to show you that you can approach these bar graph problems with averages completely visually just by thinking about where the balance point would be. I hope you found this strategy helpful. It's definitely a lot quicker than doing lots of computations. If you have any questions or suggestions or requests, please feel free to leave them in the comments below. And you can subscribe to this channel to be notified of the latest videos. I enjoyed working together, and I look forward to seeing you again soon.